An observer is 20 meters off of the ground, and they're looking down, they're observing this elevator that is rising. What we want to figure out is the angle of elevation is the angle created here between the height of the observer and the height of the elevator. The question is, as the elevator rises, how fast is that angle changing? This diagram is kind of messy, so I'm going to just try to simplify it by drawing a right triangle off to the side and working with that. So I'm going to label this angle as theta. The distance here from the observer over to where the height of the elevator is equal to this distance along the bottom. It's also 18 meters. And this first part of the question is asking us to label the height between the observer and where the elevator is as h. So we want to label this side as h. So we want to write an equation that relates theta, h, and 18. And there's a trig function that we can use to do that, and that is tangent. Tangent is the opposite over the adjacent, so there's our equation. Tangent of theta is equal to h over 18. Now, we need to know the rate at which theta is changing, so that means we have to differentiate this equation. All right, let's do that off to the side here. So let's copy this down again. We know that tangent of theta is equal to h over 18. If I take the derivative of tangent, just tangent, I know that goes to secant squared of theta, but I have to multiply by d theta dt because theta is within the function tangent. So that comes out by the chain rule. On the other side of my equation, I can really think of this 18 in the denominator as 1 over 18. So I'll take the derivative of h with respect to t and multiply it by 1 over 18. Turns out this side is pretty simple too. We get 1 over 18 times dh dt. And since we want to solve for d theta dt, I'll take secant squared, divide it, and I'll place it in the denominator here. So this is our expression. It is 1 over 18 times secant squared theta times dh dt. Okay, we're on to the part where we can now determine the rate at which theta is changing when the elevator is 11 meters above the ground. To do this, I need to know dh dt. So that comes from here. We're told the rate at which the elevator is rising. So I know that dh dt is going to come from this 4 meters per second. But we're also going to need to know, well, what is secant squared of theta? I think this is going to take a little bit of work. So here's what I mean. Secant of this angle is the hypotenuse over the adjacent. So if I want to figure out secant of theta, I first need to know the length of this side, and then I'll divide it by 18. To get secant squared, I'll take that expression and square it. So, what is the length of the hypotenuse, which I'll call lowercase h? I need to know what is the length of this side. Well, I know that capital H squared plus 18 squared is equal to lowercase h squared, and that comes from the Pythagorean theorem. If I take the square root of both sides, h is the positive solution, so that would be the square root of h squared plus 18 squared. So we're getting closer. I want secant squared of theta. I'm going to start with, well, what is secant of theta? Secant of theta is equal to the hypotenuse over the adjacent, which is 18. If I want secant squared, that means I square both sides. And I get that secant squared of theta is equal to, if I square the square root, I am left with h squared plus 18 squared. And in the denominator, you have to square 18, and I'll just leave it for now as 18 squared. Okay, so we basically have almost everything that we need. We have that secant squared is this, so I'll plug this into here. I know dH dt, that comes from here, and I'm going to start simplifying this expression. So, that is d theta dt is equal to, okay, it's 1 over, we have 18 times, okay, we got h squared plus 18 squared all over 18 squared. And this is being multiplied by dH dt. Technically, h is decreasing in size. A height of 11 meters means the elevator is still below, so this length h is dropping. In fact, it is decreasing at a rate of 4 meters per second. I just have to carefully simplify this expression, figure out what h is equal to get my value for d theta dt. All right, let's see. Well, I can cancel that with one of those. When you divide by a fraction, you can multiply this 18 to the first power to the numerator. So that's what I'm going to do. Moving along, it's 18 over, okay, we have h squared plus 18 squared, and that negative 4 I'm going to multiply into the numerator. So the question is, what is h? We're told the elevator is 11 meters above the ground, but h is the distance from the elevator up to the height of the observer, so I really want to use 9 for h instead of 11. So what I'm going to do is plug in h is equal to 9, and that's going to go right here. I'm going to simplify this, and that is the answer to this part of the question. Okay, so after plugging h equals 9 into this expression and simplifying this fraction, I got that the value negative 8 over 45, and that's radians per second. But just be a little careful here. It does state within the problem that it may be positive or negative when talking about this angle of elevation. So when they're asking for how it's changing, I think we really just don't want to include the negative in this case. So we're just going to say it's changing by this amount. So kind of like whether it's decreasing or increasing is kind of irrelevant for the question, for the answer that they're looking for. Now for the next part, when the elevator is 29 meters above the ground, so that would be 9 meters above this spot here. It turns out for this part you'd have to figure out what h is, but if you're 9 meters above, you're still using h equals 9 in this very same expression. That might not be true for every problem that you encounter here, but because it is the same for mine, the angle of elevation is changing as the same rate in this part. So that is also 8 over 45 radians per second. You just want to make sure that, for these parts, you're choosing in the correct value for h.